Hello, this is Mrs. Mitchner, and today we're doing 10.3 Day 1 notes. So make sure that you have, first of all, an Inspire calculator on your desk, because we'll be using that here in a little bit, and then your notes. And I also typed up a guide for your Inspire steps, and you can either have that out or maybe get that a little bit later if you need that to be working on your homework. Okay, so 10.3 notes, what we're going to be working on today is absorbing states and figuring out, think about going into like a maze and you get into a particular room and you can't get out. That would be considered an absorbing state. Just to kind of go through a few definitions. You could read those in your notes, but I have some abbreviations or interpretations included in these recorded notes. An absorbing state is just meaning once you are in this state, it is impossible to leave. So it's kind of like getting caught in those. Now, we're going to designate your absorbing state here in red. If you look at this, if PII, now this is real important right here. You're looking at that part right there. That means the row and column number have to match up. Like it has to be row 1, column 1, or row 2, column 2. So those two values have to be the same. If that value is equal to 1, then the state in the II position of your matrix is called the absorbing state. So it could be in row 1, column 1, row 2, column 2, row 3, column 3. Now, an absorbing Markov chain contains at least one absorbing state. It has to be possible to go from any non-absorbing state in that matrix to an absorbing state in one or more stages. And I am going to show you some examples here in the next slide. Okay. So if I look at this first one, example 1, this right here is, when I look at these to decide if it's the directions are, let me go back a minute. The directions are to determine if the Markov chain, whose transition matrix P is given, is absorbing or not. Okay, I see a probability of 1, but that is in row 1, column 2. These two things do not match. I don't know why my pen's not working right now, but it was row 1, column 2. That does not match. So that is not an absorbing Markov chain. PII did not equal 1. Okay, going on to this next one. Part B. Part B, I see that I have a 1 there. Now notice that is in row 2, column 2. Okay, so that matches up. So that is an absorbing state. But can you get there from any other state? So I'm going to label these like 1, 2, 3, 1, 2, 3. Let's say I start in state 1 right here. I can go from state 1 to state 1 and from state 1 to state 3. I cannot go boom right here. I cannot start in state 1 and go to state 2. So I need to try state 3. State 3, I can start in state 3 and go to state 1, but I can start in 3 and go to 3. But is there any way I can start in either 1 or 2 and get there? And the answer is no. So I cannot get to state 2 from state 1 and state 3. So that is not a absorbing Markov matrix, Markov chain. Okay? So it's real important. You have to be able to go from any non-absorbing state, so each one of these, 1 and 2, to the absorbing state. Now, this one's not in your notes, so you can add this in. Here is matrix C. I have 1, 0, 0.5, 0.5, so I'll give you a couple minutes to write that down. Now, if I look at this one right here, 1, 2, 1, 2, I look at the probability of 1, 1. Let me write that out. The probability of 1, 1, row 1, column 1, is equal to 1. That is an absorbing state. So I could say that state 1 is absorbing because the row and the column matched. So now I'm going to look and make sure if I start in state 2, can I get to state 1? And if I look there, yes, with the probability of 0.5. So yes, this is an absorbing Markov chain. Okay, so moving on, I have in example 2, the directions say to show that the Markov chain with transition matrix P, which I have denoted here, is the transition matrix of an absorbing chain, and write the matrix in canonical form. Well, what in the world does that mean? Maybe I should read the paragraph above that. When working with an absorbing Markov chain, it is convenient to rearrange the states so that the absorbing states come first and the non-absorbing states follow. The states will be relabeled and the transition matrix will be altered. The transition matrix labeled in this way is said to be a canonical form. It's in canonical form. Okay, so if I look at this one, first of all, I want to get the absorbing states in the upper left-hand corner. So this right here, I'm going to circle it in red. That 1 needs to be in the upper left-hand corner. So I'm going to label this state 1, 2, 3, 1, 2, 3. Okay? I'm going to rewrite this. Okay, I had to pause that and rewrite this because I wanted them side by side. So I'm going to rearrange this. We said that 1 was our absorbing state. So I'm going to move that in the upper left-hand corner, and now that is 2, 2. Let me put those in a different color. This is 2, 2. Okay? That is the only absorbing state, because it's row 2, column 2. That's the only that's the only probability of 1 that I see. So the other two states that are left are 1 and 3. Now it doesn't really matter what order you put them in. I always like to put them from lowest to highest. So then I have to go back to my matrix, and I'm looking at what is row 2, column 1. So if I'm looking at row 2, column 1, that is my one. That is not my 1/3. Let me see. How do I go back? There we go. Row 2, column 1, right there is my 0. So row 2, column 1 goes over here, the 0. Now I'm looking to fill in this space right here, which is row 2, column 3. So you're just moving everything over. So row 2, column 3, I'm looking over here is right here. It's a 0, so I'm going to put a 0 there. Okay, so let's fill in row 1. Row 1, column 2 is right here. It's a 0. Row 1, column 2. Row 1, position 1, 1 goes here. Position 1, 3 is 2/3, and it goes at the end. So now it's basically rearranging your rows. I go 0, 1/3, 2/3 for row 1, which happens to be in the middle of my matrix, right here. Okay, now let's go look over here. We're looking over here at my row 3. On the left matrix, my row 3. 3 to 2, right here, row 3, column 2 is now going to be 1/2, moves there. Row 3, column 1 is a 0, and row 3, column 3 is 1/2. Okay, so see if you need to help each other out on figuring out how to rearrange those orders. It's just real important that you look at, say, row 2 is now the first row up here in the right side matrix. I go 2, 2, 2, 1, 2, 3. So I look on the left matrix. What is 2, 2? 2, 2 was 1, 2, 1 was 0, 2, 3 was 0. So it's 1, 0, 0. Okay? Pause the video if you need to and help each other out. But we'll be doing some more. We're going to do example 3. Example 3 is up next. And we're going to be doing the same thing. Subdivide this transition matrix of an absorbing Markov chain. And it says to find the matrices S and Q. So maybe I need to go down and look underneath example 4 and see what that means. If I take my matrix P and put all the ones in the upper left hand side, I'm going to get in this upper left hand side an identity matrix. It will be square. What will happen is on the left side I'll get a bunch of zeros. Then this matrix down here will be called matrix S, and then this subdivided matrix part will be Q. Okay, so that's what we're going to look at first of all, is getting all the ones in the upper left hand corner right there. Then what will happen, everything else will fall into place. The zeros will be in the upper right hand corner, S and Q then we will identify. So that information is listed below example 4. I'm going to go zip back up to example 3, and we're going to rearrange this so I get my absorbing states in the upper left hand corner. Let me see if I can pull up a highlighter. There's a yellow highlighter. Okay. In example 3, I'm going to look for absorbing states. I see a 1 right here. I'm going to highlight it in yellow. I'm not sure if you can see it or not. Let's try a different color. Maybe this green thing. Here we go. Here's another 1 right there. So if I look at those are possible absorbing states. Now I'm going to label these 1, 2, 3, 4 down the left column, and 1, 2, 3, 4, that's a 3, it's not showing up for some reason, above the top rows. Now if I look at the yellow dot, that is position 2, 2. The row and the column match up, so it is an absorbing state. If I look at the one that's in green, in the lower right hand corner, that's in row 4, column 4, so the 4s are the same, so that would be an absorbing state as well. I wrote so big it's going to be hard to get this on the same screen for you. I'll try. So I want to rewrite these. State 2 would be absorbing, so I'm going to put a 2 up here. Oh, my pen's not working. Okay. Row 2, column 2. My other absorbing state was 4. So I'm going to put the 4s next. So I go 2, 4 along the top row and along the left column. Now the other 2 non-absorbing states, what row and column are left? 1 and 3. I'm going to put those in numerical order, 1 and 3. Okay, so if I look at this, 2, 2 in my matrix is a 1. What is 2, 4? 2, 4 is a 0. Row 2, column 1 is a 0. And row 2, column 3 is a 0. So I filled out that top row of row 2 and rearranging. Now I'm going to go to my row 4 in my purple matrix. Row 4 in my purple matrix, I'm going to pick out 4, 2 first. 4, 2 in my purple matrix is a 0. 4, 4 in my purple matrix is a 1. 4, 1 in my purple matrix is a 0. And 4, 3 in my purple matrix is a 0. Okay, moving on. Go to the purple matrix, which is a top matrix. For those of you who can't, I don't know, I hope that's looking purple up there, if you can't really tell. The top matrix, row 1, column 2 is 1/4. Row 1, column 4, position 1, 4 in the top matrix is 1/4. 1, 1 is 1/4. And what do I need? 1, 3 is 1/4. Oh, those were all 1/4. I just realized that. Whoops. I could have just wrote it all down. It really didn't matter. Okay. In the top matrix, row 3, 3, 2 is a 0. 3, 4 is a 0. 3, 1 is a 1/2. And 3, 3 is a 1/2. So there is my matrix now in canonical form. Now I'm going to put a little divider here. Let me see if I can put in, I'll put in a dotted line. Dotted brown. Okay, now the way we're going to divide this is, you see this little in the upper left hand corner? If you put a little dotted line in here and here, I want you to look at that upper left hand corner. Do you see a 2 by 2 identity matrix? Yes. That's what I would call I. This upper right hand corner are all zeros. This lower left hand corner right there will be our matrix S that we'll work on the next few days. And this matrix right here on the right is what we call matrix Q. So we're just going to identify those. If I needed to rewrite these, S would be matrix 1/4, 1/4, 0, 0. Matrix Q would be 1/4, 1/4, 1/2, 1/2. And we'll be working with these in the next few days. Definitely today, matrix Q, and then S a little bit later. Okay, so let's try another one. Let's do example 4. Okay, I'm going to try and squeeze these in the same screen here. So if I look at this, example 4 with the same directions, we're going to subdivide this into matrices S and Q and pick those out. This one's just a little bit larger. I'm looking for ones. There's one. And I'm looking for another one. I'll put that in green. There's my probabilities of 1. Now, 1, 2, 3, 4, 5. Well, this is a nice big matrix. 1, 2, 3, 4, 5. Put a 1 there. Okay, so if I look at the yellow matrix, it's in row 4, column 4. So yes, that's absorbing. So I'm going to put maybe a 4 here and a 4 here. And my green one is in row 5, column 5. So since those numbers match up, oh, look what I did. Did you catch that mistake? 4, then 5. 4 and 5, so those are both absorbing states. And the non-absorbing states that I have left are 1, 2, and 3, and I put those in numerical order. 1, 2, and 3. Now I want to reiterate, it doesn't matter on the order of 1, 2, and 3, but I just think it's, if we all do it the same, it'll be nice to compare answers when we're working together. Now if you want to try this one on your own, you can pause me and then check your answer here in a little bit. So if you want to try putting that in order by yourself, just have somebody hit pause and then you can continue here in a minute. Continuing on here, if I put in my 4, 4, that's a 1. So I'm looking at row 4. 4, 4 is 1, everything else is zeros. When I go to row 5, 5, 5 is a 1, so I'm going to put a 1 there. At 5, 5, everything else is zeros. Then I go to matrix 1. 1, 4 is a 0. 1, 5 is a 0.5. Might be easier just to look at 1, 2 is a 0.5. Everything else was zeros. Looking at row 2, 2, 3 is 0.9. 2, 5 is 0.1. Everything else was zeros. Looking at row 3, 3, 4 is 0.7. And 3, 5, no, yeah, 3, 5 is 0.3. Everything else is zeros. Now, to divide it up, I'm going to get my little fancy dotted line here. I'm going to look for the identity matrix in the upper left-hand corner. It appears to be a 2 by 2. So there it is divided. Where this is my identity matrix in the upper left-hand corner, upper right-hand corner I get all zeros. Lower left-hand corner will be my S matrix. Lower right-hand corner is my Q matrix. If I had to rewrite those to identify them, S would be 0, 0.5, 0, 0.1, 0.7.3. Identifying matrix Q, 0, 0.50, 0, 0.9, 0, 0, 0. Okay? There we go. Okay, going back to that box below number example 4. We are going to be doing in the next 2 examples, taking our subdivided matrix, and we're going to be finding a fundamental matrix T. Now that fundamental matrix T is found by taking I minus Q and then raising it to the -1 power. Now the interesting thing about matrix T, and this is what you're going to have to remember, the entries of matrix T give the expected number of times the process is in each non-absorbing state, provided that the process begins in a non-absorbing state. So basically it's going to tell you if you started in the non-absorbing state 1, how many times are you going to be in state 1, how many times are you going to be in state 2, and basically all the times before you get to the absorbing state. Now, if we were going to take and add the rows in our matrix T, the expected number of trials before absorption for each non-absorbing state is found by adding the entries in the corresponding row. So say you wanted to know how many times are you going to be, in all the states before you get absorbed. You would add that row of matrix T. And that's what we're going to figure out in the next two examples. Now, this is where the calculator work comes in handy. So make sure you have your calculator, and let's get moving on that. All right, so here we go. First of all, I have example 5, and I have an absorbing Markov chain with the transition matrix listed. Now, what I'm going to do is I'm going to sit here and divide it up. It's already in canonical form. So this right here is my matrix Q, and that's what we're going to be working with today, matrix Q. So if you want to out to the side, you can put Q is equal to, and then your 2/3, 0, 2/5. I don't know why this pen is not working really well. This is Q. Let me write it down here. That's not helping either. Having issues. 2/3, 0, 2/5, 2/5. That's a 0 right there. There we go. So that's our matrix Q. Now, the nice thing about it is, yes, we can use our calculators. So we're going to be finding our T matrix, which is our identity minus our Q matrix raised to the -1 power. Now notice Q is a 2 by 2 matrix, so that means I'm going to be finding a 2 by 2 identity. So I always start with parentheses. Okay, start here with parentheses. That's the first thing you need to do. Oh, you might need to go to Home, and you need to start a new document first. So go to Home, on the Home key on your calculator, start a new document, pick a calculator page, and then find the parenthesis key. Now the parenthesis key is located to the left, down there by the 0. If you just press the left parenthesis key, this is what it looks like. It actually does the left and the right. Okay, inside the parentheses, so we're starting with the parenthesis, we need to find a matrix template. Now the matrix template is located right next to the number 9. And when you press it, this right here comes up. It's a bunch of templates. We want a 2 by 2 matrix, and if you look right there, boom, that's a 2 by 2 matrix. So arrow around until you get that one, click on it, and this is what it should look like, your 2 by 2 matrix. Okay? Now, in that 2 by 2 matrix, you want to put your identity. So 1001, and again, you might have to pause this because I might be talking too fast. Again, my pen is not working real well. IDEN. I better stop there. Identity matrix right there. Okay? Then make sure your cursor is to the right of the matrix. Maybe if I try a different color. No, sometimes it gets it, sometimes it doesn't. Make sure your cursor is to the right of the matrix, and then you put in your minus sign. And then you will have to go to your template key again and select another 2 by 2 matrix so you can plug in your matrix Q. So here's what it looks like before I put in my Q. This is ready for matrix Q. Help each other out. In my next slide right here, you're seeing matrix Q typed in. That's my 2/3, 0, 2/5, 2/5. You don't really have to use your fraction key. Just hit 2 divided by 5. It shows up like that. The fraction key I started to use and it made it just look too like it was too much there. Okay. So the last two slides here is just showing you how, okay, I need to raise it to the -1 power. So I find the caret button. The caret button is, let me think here, it's on the left side of the calculator. I don't have it in front of me. Um, is it the left side of number 4? Yes. To the left of 4, you will see your caret button. That's that arrow up key. When I say caret, it's like that key. Raises it to a power, and then you just type in -1, and then you hit enter. So then your final answer here is down here. I get 3, 0, 2, 5/3. That is my final answer. Now, these were from matrix Q. These are my non-absorbing states. These are states 3, 4 here and 3, 4 here. If you go back to your original matrix Q and look at the tops are columns are labeled 3, 4, and the left rows are labeled 3, 4. Okay? These are actually the expected values. So to interpret this, let me get my little highlighter out. To interpret this, I would look at this and say, okay, if I start in 3, I will, for 3 times, or 3, I don't know, times that you play the game, I'm going to stay in state 3, and I will be in state 4 0 times before I'm finally absorbed or get into a room where I can't get out. If I start in 4, that means twice I'm going to be in state 3, and 5/3 of the time, or 5/3 times, I'll be in state 4. Now I know we can't actually be there a fraction of a time, but that's, remember, expected value is not really a number that you're going to actually use. It's just on average if you're to play the game many times. If you start in stage 4, I'm going to stay in stage 3 twice, and stage 4 5/3 times before I'm finally absorbed into a state and can't get out. Now that's what that means, and that's your fundamental matrix. That's your answer for part A. So for part B, it says if the chain is initially in state 3, boom, right here, okay, state 3. Find the expected number of transitions before the system first reaches the absorbing state. So that means you add row 3. Add the entries in row 3. 3 plus 0, I think we can handle that, 3. So the expected number of times that the row 3 is in non-absorbing states before it's absorbed is 3. Okay? So it'll be in state 3 3 times, state 4 0 times, and then be absorbed. That will be it. Okay? Now let's do example 6. We're almost done here. Last example. Oh, there's a big matrix. Okay. So we have to first of all rearrange that big thing. I need to find my, basically I'm looking for my probabilities of 1. Probabilities of 1 right here. That is in, let's label it, 1, 2, 3, 4, 1, 2, 3, 4. So it's in state 3, 3, so that is an absorbing state because the row and the column match up. So up here I'm just going to put my matrix here. Oh, I better use a different color. Let's use black. So I'm going to put a 3 here because it was row 3, column 3. And then the others are not absorbing, so I'm just going to put 1, 2, and 4. There's my 3, 1, 2, and 4. So 3, 3 was a 1. If I want to look at that matrix, the rest of the entries are zeros, so I can put those down. Then I go back to matrix, or to row 1, and I have to pick 1 to 3 is 1/6. 1 to 1 is 2/3. I can't look at that. I'll have to look at my notes. 1 to 2 is 1/6. And 1 to 4 is 0. So I'm just looking at the blue matrix up there and figuring out, rearranging these rows. 2 to 3. 2 to 3 is 1/9. That's a 9. 2 to 1 is 1/9 again. 2 to 2 is 2/3. And 2 to 4 is 1/9. Rearranging row 4. 4 to 3 is 0. 4 to 1 is 0. 4 to 2 is 1/3. And then 2/3 is left. Okay? So there we go. What am I supposed to do? A Markov chain has a transition matrix, the blue one. A mouse begins in state 2. Find the expected number of transitions before the mouse reaches compartment 3. Now basically compartment 3 is an absorbing state. So it wants to know the number of transitions before the mouse is absorbed, basically not literally absorbed. I would say reaches compartment 3 and can't get out, like a room that cannot get out. The trap door is shut, that mouse is dead. Or maybe not dead, but you know what I mean. Okay, so I need to put this, it's in canonical form. I want to put in my dividers. Now, oh wow, I'm looking for an identity. The only identity I see is going to be that one, a 1 by 1. That was kind of different. I'm glad we did that. Okay, so if I'm looking at matrix Q, you can rewrite it if you want, but there's my Q matrix. It's going to be a 3 by 3. This is my S matrix. Not going to use it today, but that's what it is. Is this matrix all zeros? Yes. Is this an identity? Sure is. It's a 1 by 1. Okay, now we're ready for some calculator steps. Okay, just remember this is your Q matrix. Make sure you have that written down on your paper. That's what we're going to be using in our matrix, in our calculator. Alrighty. This one I just might go a little bit faster, and you've got your steps so you can kind of work through this. Make sure you're working through this on your own, or with a buddy. Make sure that you're actually following along, figuring out how to use this calculator. Okay, so remember, we're going to start, at least I did, on a new page. So I hit, I think it's control, oh shoot, I forget. I think it's control doc to hit a new page. Control doc has a plus page at the top of it. This thing is not working. Darn. Okay. You don't have to start a new page, but it cleaned it up a little bit for me to be able to do this on my document here. Okay, so start with parentheses. And in this case, remember we're doing our transition matrix. This is what we're doing. Parentheses, I minus Q, that's a Q, raised to the negative 1. Okay? So you start with your parentheses. Now this time, when you go to that template by the number 9, that template button, you do not want a 2 by 2. So you want to be able to pick any size you want. So this is it looks like a 3 by 3 matrix, but actually this is a screen that comes up and you can put whatever dimensions you need for the matrix. So that's kind of like the generic matrix. This one right here was just if you needed a 2 by 2, but here's the matrix key you'll probably use all the time. I just wanted to be able to show both of those to you so you know that you can use those. Okay, so pick 3 by 3 and then hit OK. Press OK right there. And your 3 by 3 template will come up. Put in your identity. And then you've got to make sure your cursor is to the right of that matrix. Press your minus sign. Select another 3 by 3 matrix. Basically, this will be what you need right here. Okay? Well, that could be a problem. Load disk space. All right? So I have I minus Q inverse. Pause this and get that all done, and then we can come back and discuss that final answer. Okay? All right, final answer that I got was right there. 431, 262, 262. There's my final answer. Got it? Now, look back in your original matrix. These are the non-absorbing states. I always write these down. 1, 2, 4, 1, 2, 4. Now I do that because it tells me that this mouse begins in state 2. If the mouse begins in state 2, this is the row I'm going to look at. The mouse stayed in state 1 twice, it stayed in state 2 6 times, and state 4 2 times. So before it got to a room that it could not get out of, before it was absorbed, it was in other rooms 10 times. So the expected number of transitions is 10. Okay? So it stayed twice in row 1, or like room 1, 6 times in room 2, and 4 times in, 2 times in room 4. And I think that is it. All right? You guys have some time to work on your book work. Make sure you get your book work done so you can use your calculators here in class before you leave. Have a good day.